static electricity work? Why do we get static shocks? Why does bouncing on a trampoline make our hair look like this? Well, maybe not mine, mine's a bit too short for that. To understand static electricity, we have to think about what is inside atoms, the tiny, tiny particles that everything in the whole universe is made of. The atoms have a nucleus inside their centre. It's made of protons and neutrons. The protons have a positive charge and the neutrons are neutral. They have no charge. So overall, the nucleus is positively charged. Electrons, however, are negatively charged. They whiz around outside the nucleus. Usually, the positive and negative charges are equal, so everything is in balance. The atoms have a neutral charge overall. So what's this got to do with static electricity? Well, electricity is just moving electrons, hence the name. When electrons carry electrical energy by moving in wires, we call it electricity. But when electrical energy builds up in one place, we call it static, which means still or not moving. So how does electrical energy build up in one place? Electrons are tiny. They have such a tiny, tiny amount of mass that they can move easily from one object onto another. And when two different insulators, like a balloon and a cloth, are rubbed together, the force of friction gives electrons enough energy to move away from their nucleus and onto the other insulator. As the negatively charged electrons have been removed, an area of positive charge is left behind. This difference in charge is called a charge imbalance. When insulating objects are charged like this, they can exert electrostatic forces on each other. Charges that are the same, like positive and positive, repel each other, and two that are different, positive and negative, attract each other. Nature hates things being out of balance, so this charge imbalance can't stay like that forever. A charged object needs to get rid of the extra electrons by sending them to the ground. And as soon as anything connected to the ground comes close, those extra electrons jump to it to discharge to the ground and redress the balance. That is a static shock. The electrons get back to where they should be and everything becomes neutral again. So, if you're jumping on a trampoline and your hair stands on end, it's because you're charged. Electrons have been transferred and all of your hairs have the same charge, whether that's positive or negative. So they repel each other, trying to get as far away from each other as they possibly can. When you touch another person or something else that's connected to the ground, all those electrons jump back to where they should be and electrical balance is restored.